Hi, welcome to the video, Functions versus Relations. In this video, we're going to talk about what a relation is and what makes a function special. So what is a relation? A relation is a set of ordered pairs. Think of it as a set of points. It can be represented by a list of pairs, a table, a graph, or even an equation for those pairs. So in this example, we see the same relation represented in three different ways. All right, so now that we know what a relation is, what is a function? A function is a set of ordered pairs in which every element in the domain is paired with only one element in the range. There's a lot in there that we need to unpack, so let's take it piece by piece. So the first part is a set of ordered pairs. Well, we just talked about what a set of ordered pairs is. Right? That's really a relation. So a function is a special type of relation. Another way of representing that, if you want to think of this green blob as representing all the possible relations, right? Functions are like this little group that fit within that. Every function is a relation, but not every relation is a function, right? So think of something that is just a relation over here that doesn't follow this rule would have to be over here, whereas a relation that does follow this rule would be a function and it would live in here. So like, what is this rule? Let's break that down. Every element in the domain is paired with only one element in the range. Well, domain is talking about inputs or x values. Range is talking about outputs or y values. So what that really can be reworded as is that every x value is paired with only one y value. So let's take a look at this more closely. Here's our example again. Is this relation, right, it's a set of points, is this relation a function? I say no, it is not a function, right? And it's because not every x value is paired with only one y value. Let's look at it at all three representations. Notice that when it's listed as a set of points, by the way, these little curly brackets here, those are called set brackets. See how we have 2, 0, right? So 2 has been paired with 0. 2 has also been paired with 5. So that breaks the rule. Not every x value. 2 is not paired with just one y value. We can see that in the table as well. In the graph, we actually see something special, and that's going to lead to a little shortcut that we could use to figure out if something is a function or not. So notice these 2 points are in a vertical line with one another, right? That would mean that they're sharing that x value. If this is what happens on the graph, that's what is going to tell us that this relation is not a function. So let's formalize that. Let's talk about this vertical line test. So if you have a vertical line, think of it as like an invisible line, or even like take a ruler or your pencil, like something that you can see and put it on a graph. If that line goes through more than one point at any x value on the graph, then that relation is not a function. So let's take a look at some more examples and use our vertical line test to see if it's a function. Okay, so on our first example, right, we have this blue graph. Notice that if I were to take this invisible line, right, and make it visible, see how that vertical line only touches this one point? And if I made vertical lines wherever I wanted to, there'd be some places where I don't hit any points at all. That's fine. But everywhere else, I'm only touching one point at a time. So I would say that this is a function. It passes the vertical line test. I'm even going to say V LT for short. Let's take a look at the circle. What happens if we put a vertical line through this circle? Ooh, that time we crossed the circle at 2 different points. That means that this x value is paired with more than one y value, right? Right here it fails, but look at how many places on a circle it's going to fail. Everywhere except, I'd say, right here and right here. But everywhere else, it's going to have 2 points on that vertical line. So we'll say this is not a function because it failed the vertical line test. So I like using the graph to test if something's a function. Sometimes we don't have the graph and we have to look at either a set of points or a table of points. We also have one more tool that we're going to talk about. But let's take a look at just one more example before we get to that last tool. I thought I'd throw in one that looks kind of weird, right? So is this relation a function? Let's take our vertical lines, right? Something else that I like to do, especially when I'm in person, is that I take my ruler and I move it along the graph and I have it make the sound like beep, 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 beep. And when I hit more than one point, it freaks out, beep, 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 beep. Okay? So I'm just gonna kind of do that right now. So like beep, beep, beep. Think about why that didn't go crazy. How many points am I touching on this last line that I just drew? That's a point. That is not a point. Those are considered empty right there. So that didn't cause any problems yet. It's still passing. Beep, 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 beep. Right? And everything seems to be fine. As weird as that is. It's actually called a step function. This one is a function. I'm going to write the real reason it's a function. I know it passed the vertical line test, but I'm going to use the definition right now. This is a function because every x value is paired with only one y value. So you might have to use that definition to explain why something is a function. Sometimes it's okay to just say, yep, it passed the vertical line test. Sometimes we ask you to use that definition. All right, so on to the last tool that I promised to talk about when we don't have graphs. And that is a mapping diagram. You may have seen these before. Think of it as a table, but it's been adjusted a little bit. So here we have 4 points, right? 4 pairs. We see exactly how they've been paired up because we know that in a table, these numbers are paired together, right? Straight across like this. When we are using a mapping diagram, we don't repeat values, okay? Not that these had repeats in it, but what we normally do, and that doesn't have to happen, we normally put these in order. Like here we have the 1, 6, 8, 9. And here, look, notice the range is in order. And then the arrows kind of go crazy, right? But you can still see what the pairs are. But here's the important thing, is that we don't repeat the values that are in the domain, and we don't repeat the values that are in the range. So I only have one of each of these values. Let's try making one, and you can see why it's going to be useful to see if something is a function or not. Okay, so we have a table, 5 pairs, and we're going to create a map. So we're going to have our x's over here. I'm going to call that the domain. And the range over here. So in my domain, we have -3, 9, negative 3, I just wrote that down. I'm not going to write that down again. 0 and 2. And I could reorder these if I want. I don't think it's really necessary at the moment though. Now I'm going to do the range. 4, negative 1, 5, 7, 0. Okay, I didn't have any repeats there. Now what we're going to do is connect them with the arrows. So negative 3 went with 4. 9 went with negative 1. Negative 3 goes with 5. 0 is paired with 7. 2 is paired with 0. So that's how we create a map diagram. Now here's the reason why we like to do this. Take a look at the arrows. Notice how there are 2 arrows coming off of the 3. See this right here? That is what we're looking for. If something like that happens, that means that what we're looking at, this relation, is not a function. So we're going to write that down. This relation is not a function because, well, what's the reason? An element in the domain, oh, we could have also said an x value, right? That's just a fancy way of saying that, is paired with more than one element in the range. Or we could have said y value, right? So this map is a nice visual of seeing that pairing. Obviously, we could have made a graph as well, but sometimes this is a little easier than making a graph. Let's just go through these examples quickly so that we can see different things that can happen. Okay, so notice in this example here on the left, negative 1 has 1 arrow, 0 has 1 arrow. Each of these domain values has 1 arrow. That's what I'm looking at. I'm looking at the number of arrows coming off of the domain. See in the range how the 5 has 2 arrows coming at it? I don't care about that. That has nothing to do with it. My focus is all here. So I'm going to say this is a function. Second example, let's see. I think we're going to start out with it being a not function right away here. We got negative 2 going with 1, negative 2 going with 3, 2 arrows coming off of that. That is not a function. Also notice that I'm not saying it's a relation. That's not the answer. Functions are relations. Not functions are relations as well, right? It's important that we say this is not a function. You're either a function or not a function. This is one of my favorite examples, right? Looks like a lot or everything is paired with 4 here. But remember, we don't care how many arrows are coming into this output. I'm just counting the arrows coming off of the inputs. 1, 1, 1. That's a function. So hopefully now you're able to look at either a graph, a table, or a mapping diagram and able to tell if it is a function or not. All right, good luck with your practice.